In everyday life, we refer to a solution as a way to solve a problem. But in science, solution can mean something else. A solution is a combination of two or more compounds. Typically, we refer to these compounds as the solvent or the solute. A solvent is the material used to dissolve another material into it. A solute is what is being dissolved into the solvent. For example, we can have a solution of sugar water. In this example, the solvent is the water and the solute is the sugar. When we talk about the concentration of a solution, we are typically referring to the concentration of the solute in a solvent. In other words, how much solute there is in comparison to solvent. Water, a solvent, can only hold so much solute, such as sugar, before the solute can no longer dissolve into the solvent. In this case, the solute will fall out of solution. A solution can be dilute or concentrated. A dilute solution is a solution that has very little solute in the solvent. This is often done to make the solute less potent, such as in the case of hydrochloric acid. Hydrochloric acid can be very dangerous, but if it is dilute, then it is not as dangerous to use. Its dilute form makes it much easier to work with. A concentrated solution is a solution where the solvent has a lot of solute in the solution. A solution that is filled to capacity is called a saturated solution. There are many compounds that are not active unless they are dissolved into solution. Yet we still want the full potency of the solute. In these cases, we will use a concentrated solution. It won't do us any good to fill the solvent beyond its saturation point, as the excess solute will simply fall out of the solution. But we can experiment to determine what is the maximum that a solvent can hold before it reaches its saturation level, which is based on the solubility, or how easily it goes into the solution of a solute. Based on our needs, we can have a solution on a continuum between dilute and concentrated. Maybe we want to only slightly dilute a compound. We won't fill the solvent to its maximum, but we might put in slightly less of the solute than the maximum. Concentration can be calculated as long as you know the moles of solvent per liter, or molarity. For example, we might say a 1 m solution of hydrochloric acid. This means that there is 1 mole of hydrochloric acid per liter of solution. So what does that mean, and how do we know that there is 1 mole in the liter of solution? First, let's review what a mole is. This is not the blind animal that lives in the ground. Instead, it is referring to a specific number of molecules. In fact, it is referring to 6.02 times 10 to the 23rd molecules of atoms. We could just as easily refer to a dozen hydrochloric acid molecules if we only wanted to talk about 12 molecules of hydrochloric acid. The nice thing about a mole is that we have determined the weight of every element in 1 mole of that element. This is called the molecular weight of that element. By adding up the molecular weight of each element found in a compound, we can also determine the weight of 1 mole of that compound. Thinking back to a dozen, this would be just like if we took the weight of 12 atoms of hydrogen and recorded it, then recorded the weight of 12 atoms of carbon, and so on. Then we would know the weight in 1 dozen of each element. However, instead of a dozen, which is way too small, we've calculated moles. So let's get back to concentration now. Let's look at a solution of hydrochloric acid. The chemical formula for hydrochloric acid is HCl. So there is 1 hydrogen atom and 1 chlorine atom in each molecule of hydrochloric acid. The molecular weight of hydrogen is about 1 gram per mole. The molecular weight of chlorine is about 35.5 grams per mole. If we add this together, we get 36.5 grams per mole as the molecular weight for hydrochloric acid. Now, let's say we have 1 liter of water and we put in 44 grams of hydrochloric acid. What would be the molarity of this solution? We end up with 1 liter of a 1.2 mole hydrochloric acid solution. We can also work this backwards. Let's say we wanted to make a 1 mole solution of hydrochloric acid. How much hydrochloric acid would we need to put into 1 liter of water? So we end up with needing to use 36.5 grams of hydrochloric acid to make 1 liter of a 1 mole solution of hydrochloric acid. Just as a side note, when measuring molarity, we would actually put in the desired amount of solute, then fill to volume with the solvent. We want to end up with 1 liter of solution, so we wouldn't actually use 1 liter of water. Instead, we would use slightly less than 1 liter. A solution is a combination of two or more compounds. A solvent is the material used to dissolve another material into it. A solute is what is being dissolved into the solvent. Solutions can be concentrated, lots of solute, or dilute, little solute, depending on our needs. A saturated solution is one that is filled to capacity with solute. We can determine the concentration of a solution in molarity, or moles of solvent per liter, by determining the number of moles of solute in a liter of solution.